మ్యాథ్స్ నువ్వు చదువుకుంటే మ్యాథ్స్ నువ్వు ఉండేది. Hello. Hello aspirants, how are you all? All good, having fun? I don't think people have joined yet. I hope the audio is clear. Let me check. Hello. Hello. Okay. So we have already discussed and have gone through the continuity part of this chapter, the continuity and differentiability. And as I told you that both the aspects of this chapter are equally important, whether it is about checking the continuity of a function or about the differentiability of the function. Continuity we discussed in the last part. The summary of the entire thing was that your left hand limit equal to right hand limit equal to the value of the function at that point. For example, if we are checking the continuity of f of x at a, then left hand limit at a of the function, right hand limit of a of the function should be equal to the value of the function at a. That means f of a. If it is true, then our function is continuous. Now about differentiability. If the function is continuous, is it okay? Is it correct to say that it will be differentiable? What is the meaning of derivative or differentiable function? Let's understand that. For example, if I'm finding, for the example, this is my function and this is some x equal to a, right? If I'm finding derivative of the function at x is equal to a, that means the tangent. This we know, dy by dx is nothing but the tangent at that particular point. Dy by dx at x is equal to a is the derivative at a. So if the function is continuous, definitely I can say here I can say that the function is continuous at x is equal to a. If I'll find the right hand limit and find the left hand limit, that will be equal to f of a. Here the function is continuous, polynomial function. This looks like smooth graph, definitely continuous, and it is also differentiable, I can say that. But sometimes even if my function is continuous, it might not be differentiable at that point. For example, over here if we check, this is my x equal to a. Yes, I know that my function is continuous at x equal to a, but we have a sharp point. If you have studied this chapter, you'll understand by differentiability we mean that the graph of the function should be smooth over there. We don't have a tangent over here. We have tangent only where the graph is smooth. That means my function is continuous at x equal to a, definitely. Left hand limit, right hand limit, and the value of the function at x equal to a will all be equal to one another. But still here my graph, here my function at x equal to a, my function is not differentiable. That I'm sure about. Correct? So now we are going to study about the concept that how to check whether the function is differentiable or not at a given point. Although we are going to discuss it later, but now you must have understood if it is differentiable, then it is continuous. This is correct to say. Yes or no? It is correct to say. let's discuss this part of the chapter, continuity and differentiability. Continuity we have understood, left hand limit, right hand limit equal to the value of function at x equal to a means that function is continuous at x equal to a. But now we have to understand that at x equal to a, whether it is differentiable or not. Knowing about continuity, we can say that yes, continuous we can say, but differentiable or not, that we have to say, that we have to understand how are we going to talk about it, or how, what are the aspects of being a function being differentiable at a point. So here, very small not very difficult. If we have understood continuity, then differentiability also we'll be able to understand. It's just that we should understand the connection and the difference between differentiability and continuity. Both the things, connection as well as the difference between these two things. If we are thorough and if we are clear with this, then we'll be able to solve almost all the varieties of questions in this particular part, in this particular chapter. Just three things we have to take care of, and exactly two, almost two varieties, no, maybe three, but I would say two varieties only. Just like in continuity we had two varieties of question, here also not much of variety is going to be there, but yeah, concept application and definitions are going to be applicable everywhere. The good part is that this chapter is explored very well. So in this chapter we are going to have shortcuts. We definitely are going to have shortcuts which will ease our problems, which are going to solve the problems faster than the methods which are written in the books. Right? If we'll look at the chapter, and if we look at the solutions in the books that we follow, we'll see that many questions are very long. Like the solutions of many of these questions are very, very long. But we are going to discuss some short methods which will solve our multiple choice questions at least very fast. Okay, so pay attention in the entire chapter. Easy concept. If you can gulp down the definitions, it is going to be easy for you to understand this chapter, and it is a very important chapter from class 12th perspective also. JEE Mains, extremely important, high weighted chapter. Lot of questions. If you are thorough with functions and continuity, this chapter is not going to, this part is not going to bother you. And this chapter, continuity, differentiability along with functions, all three, the combo of three is going to be giving you a high weightage in your JEE Mains and Advanced. Okay, so let's start. What is the meaning of differentiable? What is the meaning of a function being differentiable? So here we are going to introduce two terms, LHD and RHD. In continuity we were talking about limits, so RHL and LHL. Here we are going to talk about different derivative, left hand derivative and right hand derivative. Simple to understand, left hand derivative and right hand derivative. Okay, so two things we are going to pay attention at over here are left hand derivative and right hand derivative. Just like in continuity we paid attention at left hand limit and right hand limit. Okay, I hope, all right, yeah, left hand limit and right hand limit. Here we'll talk about left hand derivative and right hand derivative. So we know what is the meaning of f dash of x. We know what is the meaning. We know if it is f of x plus h minus f of x divided by h. Correct? Where h is tending to 0. Where h is tending to 0, h is very close to 0. So this thing is called as our derivative. We know about this. So right hand derivative would mean f dash a positive, right hand derivative at x equals a. What will be the meaning of this? What will be the meaning of this? This means f of a plus h minus f of a divided by h. This is going to be my right hand derivative. That means h is, I'm talking about the right side of the derivative. Simply by understanding the definition, you understand this, that right hand derivative means f of a plus h minus f of a upon h. Just a minute, there is an issue. Okay, this is my right hand derivative. That means h is still positive. Here also h is positive. H is positive but slightly greater than 0. Right? Now, h tending to 0 means we'll have to apply limit of h tending to 0, f of a plus h minus f of a by h, not f of h, just by h. Here if my h tends to 0, then limit h tending to 0, f of a plus h minus f of a upon h is going to be my right hand derivative. Now I'm defining derivative of f of x at a as right hand derivative and left hand derivative. That means derivative, or you can understand as tangent also, from right side of a. When we are talking about a plus means a plus h, we are talking about right side of a. And now if I'm talking about left hand derivative, you must have understood this is nothing but a minus h minus f of a divided by minus h. Here minus h will come, okay, because h is positive in both the cases. H is taken as positive in both the cases. Then only a minus h will be left hand derivative, and here also minus h will come. Okay, so right hand derivative and left hand derivative you have to understand by this. F of a plus h minus f of a by h is my right hand derivative, and f of a minus h minus f of a by minus h whole by minus h is my left hand derivative. These are two things that we have to pay attention at, or we have to remember. Not remember, we can understand. We know the definition of derivative, then we can understand right hand derivative and left hand derivative also over here. The important thing to understand is this thing, that your h is positive in both the cases. Right? Left hand derivative is this. Now what is the use of it? That I'll tell you, but first note this down, gulp this down, that right hand derivative means nothing but f of a plus h minus f of a upon h, and left hand derivative means nothing but f of a minus h minus f of a divided by minus h. First note this thing down. Great, Mohit. Now let's do a simple exemplar question based on this definition only. Okay, f of a plus h minus f of a upon h is my right hand derivative. If I'm taking a plus h is positive in both the cases. There must be a question. Okay, here is a question. F dash of a positive. Achha, here f right hand derivative will be denoted like this, f dash of a positive. We are checking the derivative at a. So right hand derivative at a will be f dash of a positive, left hand derivative at a will be f dash of a negative. Now one more thing that what you can understand is this is same like limits, right? F of h tending to 0. So this is what, this can be written like this, f of a plus 0 minus f of a divided by same 0. Right? Remember we used to do the same thing in limits also. It can be understood like this only. If we have this format, f of a plus 0, where limit is h tending to, here limit is h tending to 0, whatever is the limit, if we have limit over here, then a plus 0 minus f of a upon same 0. Format has to be remembered. It's not just the formula, you should remember the format. For example, in this question if we see, dash of a positive, that means right hand derivative at a is given to us. That means right hand derivative at a is given to me. Okay. Limit h tending to 0. Now, can you see the format? I'm sure that for the first time, if you are reading this might confuse you. But if you understand this carefully, this is just the format that we just now read, right? F of a plus h minus f of a upon h. No, f of a plus some 0 minus f of a upon same 0 if we can create, then we can say that we have the right hand derivative. So if I write over here f of a plus 3h square, where 3h square is my 0, right? Because putting h as 0 over here will make it a 0, right? So a plus 0 will be created, minus f of a divided by, what do I need? I need 3h square only, right, for creating the same 0. So I'll have 3h square. Now limit h tending to 0 was here. 1 by 2 I took out. This 1 by 2 I can take out. I divided by 3, so I'll have to multiply also by 3. I divided by 3, no? Here I multiplied 3. 1 by 2 was taken out. I multiplied 3 over here. If I'm multiplying here, then I'll have to multiply in the numerator as well. So this is going to give me what? This is going to give me this entire thing. Now this entire thing's value I know. What is this? This entire thing is nothing but my f of a positive. This is my f of a positive. H is already tending to 0. 3h square, 5h square, 100h square, whatever it is, doesn't matter. A plus 0, right? A plus 0 minus f of a divided by same 0. Same thing should be in the denominator, whatever is added with a over here. This is my a positive. Can I call it a positive? F dash of a positive, sorry. This is f dash a positive, right hand derivative at a. Yes, by definition I can call it that way. So simple. This value I know already. 3 by 2 multiplied with this thing is given to me. F dash a positive, right hand derivative at a is given to me. What is it? It is equal to 4. So this is nothing but 6. This is how by definition we can solve these type of question. These type of question can also occur at the basic level, at the board level. You can get to see this type of question. Right hand derivative or left hand derivative will be given to you and they'll ask some value. So remember the format. Format says limit h tending to 0, a f of a plus 0 minus f of a upon same 0 is going to give you f dash a positive. A minus h up minus f of a upon minus h will give you f dash a negative. Okay, this is what you need to remember. Okay. Now what does it mean graphically? What does LHD and RHD mean graphically? Now, if you see this thing, f of a plus h minus f of a upon h, this is the definition. By definition, this is a derivative, right? Here it is right hand derivative. F of a plus h minus f of a upon h is my right hand derivative. I know, right? If my h is tending to 0, right now in this situation h is not tending to 0, but graphically if I see, suppose this point is a comma f of a, this point will be a comma f of a, and this is another point a plus h comma f of a plus h. Now what is f of a plus h minus f of a? F of a plus h minus f of a, y2 minus y1, correct? Right? This is what is this written? This is nothing but y2 minus y1, y coordinate minus y1, y2 minus y1 divided by a plus h minus a. A plus h minus a means h only. So x2 minus x1. What is this? I know this is slope. Slope means this is my derivative. Slope means f of a plus h minus a upon h is nothing but slope of this AB, this line AB. It's nothing but slope of AB. Now, what did I, when I'm doing this, limit h tending to 0, f of a plus h minus f of a by h, when I'm saying this, I'm calling this right hand derivative, What does this mean? That this point h is tending to 0. That means this point is coming very, very near from the right side. This point, a plus h is this point, a minus h would be this side, a plus h is this point. That means this point is coming very, very near. Suppose if this point is here, then your line will be like this, slope will be this. If this point is here, then your slope will be this. Now this point came very, very close. This point came very, very close. That means h is tending to 0. H is almost 0. That means f of a plus h and f of and a will be very a plus h and a will be very close, and f of a plus h and f of a will also be very, very close. So your tangent will be this. This means your tangent from right side. This means your derivative, the tangent at a from right side, because this point is your f of a plus h, very, very close to f of a. This means your tangent to the curve from right side. Sir, will you come up with probability one shot? Very soon, Mohit. On the public demand, why not? Okay. That means your tangent from the right side, right hand derivative means tangent from right of a. Right of a means you have to drop the tangent. Left of a means you have to drop the tangent from left. Suppose this is left of a, then this thing. So left hand derivative means a minus h. That means this point will come close from this side. So your tangent will go on the left side. Left hand derivative means tangent from the left of a. Right hand derivative means tangent from the right of a. Graphically it means just this. So now you must have got the idea that when will we call it differentiable? We'll call it differentiable means same tangent, only one tangent. dy by dx has only one value, finite value. That means your left hand derivative and right hand derivative should be equal if you want the function to be differentiable. Getting my point? Right, this point a plus h will come very close. F of a plus h will come very close from the right side. A minus h will be over here. It will come very close to a, so your tangent will be from the left side. This is what it means by saying right hand derivative and left hand derivative at a. Okay. Hopefully we can gulp this down. So I hope this line is, f of a plus h minus f of a is right hand derivative at a becomes slope of tangent at a from the right. And same thing, LHD gives slope of tangent at a from left. That means left hand derivative. That means your limit h tending to 0, f of a minus h minus f of a by minus h is going to give you tangent from the left side at a. So at a, if we want to check the differentiability, my tangent from the right and tangent from the left should be same, and that should give me a finite value. That's what we'll mean by saying differentiability. For example, over here, consider the following graph and observe RHD, LHD at x equal to a. Now you see here, can you by graphically, if you have a bit idea, differentiable means smooth graph. Is the graph smooth at x equal to a? No. Then it will be differentiable at x equal to a? No. It is continuous at x equal to a? Yes, it is continuous. It is connected, so it is continuous at x equal to a. But whether it is differentiable, if I check the LHD, that means left hand derivative, the tangent will be somewhat like this, right? Tangent at a from the left side. Now tangent at a from the right side, that means from right of a, will be like this. So my left hand derivative and right hand derivative are different. I am getting different tangents at the same point from right and from left. And that is why I say that my function is not differentiable at x equal to a. Differentiable means same tangent should come. Same tangent should appear. Now it is continuous at x equal to a, but it is not differentiable at x equal to a. Okay. So when am I going to say that my function is differentiable at x equal to a? If my left hand derivative and right hand derivative at a are both equal and they both are equal to a finite value, then I can say that my function is differentiable at that point a. Very simple to say. Understood, hopefully? Okay, next point. Now, first point we have understood, if left hand derivative and right hand derivative are both finite, there exists a unique tangent at x equal to a. That means the graph is smooth. Graph is smooth means differentiable. So we can also say if LHD is equal to RHD is a finite value, it is differentiable. Differentiable also means smooth. Smooth means there is no harsh point or there is no peak point. There is no break. What do we call it? There is no pricky point or pricky point at x equal to a, that the graph is smooth over there. Okay, if fx has a sharp point, yeah, the word is sharp point, not the pricky point, I was forgetting. Sharp point means just like this. Over here we had a sharp point, right? Here we had a sharp point. That means it was not differentiable. So if my f of x, if my LHD is equal to RHD and both of them are giving me a finite value, that means my graph is smooth. That means it is differentiable. And if f of x has a sharp point, that means LHD and RHD will exist. There will be tangents. There will be tangents. There will be tangents, but they are not equal. If they are not equal, that means I'm getting a sharp point over here. Sharp point means right hand derivative, tangent from the right of A and tangent from the left of A. Both are different. They both are finite. They are giving a value, but they both are different. That means I can say my function is not differentiable at x equal to A, and at x is equal to A, there is a sharp point. But yeah, if both LHD and RHD are existing, can I say that f of x is continuous at A? If LHD and RHD both exist, they are giving me a finite value, then I can surely say, right, that my function is continuous at A. Think about it. Correct? That's what is written over here. Differentiable, first point is that differentiable function is always going to be continuous, smooth. Differentiable function, if a function is differentiable at that point, that means it is continuous at that point. But yeah, vice versa might not be true. Why? Because we just now saw this. We just now saw the example of this. At x equal to a, function was continuous. It was not breaking, but it was not differentiable at x equal to a. So if a function is differentiable, then I can surely say that it is continuous at that point. But if a function is continuous at a point, I cannot say that it is also differentiable at that point. This concept should be very, very clear. That if my function is differentiable, then it is surely continuous. But if it is continuous, then I have to check whether it is differentiable or not. I'll have to check with RHD and LHD, right hand derivative and left hand derivative. That I'll have to check. Next point, if a function is discontinuous at x equal to a, if the function is discontinuous at x equal to a, then the function has to be non-differentiable at x equal to a. If it is not continuous only at x equal to a, if a function is not continuous only at x equal to a, something like this, if this is the function and this is a, if my function is breaking at x equal to a, if the graph is breaking at x equal to a, my function is not continuous only, then I can surely say that it is not differentiable. If it is continuous, then I cannot say that it is surely differentiable. But if it is not continuous, then I can pakka say that it is non-differentiable. These 4 points should be clearly understood. Very important to understand the entire chapter ahead. First thing, that if LHD and RHD both are finite and both are existing and both are equal, then the function is differentiable. And if it is differentiable, then it is surely continuous. If LHD and RHD both are finite, they are existing, but They are not equal. That means I have a sharp point. Function is still continuous but not differentiable. Okay, next thing, differentiable function will always be continuous, but a continuous function might not be differentiable always, right? But a non-continuous function will definitely be non-differentiable. So if we are getting discontinuity at a point, that means we surely can say that at that point the function is not even differentiable. Okay, now very important thing, if my right hand derivative and left hand derivative are finite, then f of x is continuous at a. I told this, but it is written over here also, that if your right hand derivative and your left hand derivative both are finite, they are not equal, both are finite, both exist, right, then that means that f of x is pakka, is definitely continuous at x equal to a, even if LHD and RHD are not equal. Even if LHD and RHD are not equal. We saw the example, right? We saw the example, this one. Graph is connected. It is continuous at x equal to a. This is your x equal to a. But it is not differentiable. There is a sharp point. If you'll see, the right hand derivative will give you this. Sorry, right hand derivative will give you this. Left hand derivative will give you this at x equal to a. Right? Different tangents. So right hand derivative and left hand derivative are not equal, but they both exist. They are both finite. That means you are getting a finite value. Both can be differentiable. Right hand derivative is also possible. Left hand derivative is also possible. That means you are getting a sharp point there. Function is continuous but sharp there. It cannot be differentiated at x equal to a. This is what we need to understand. Now, why this? How, like, to prove it mathematically? Graphically, you must have understood, but mathematically also we can prove this, right? Now let's say right hand derivative. What will be the meaning of right hand derivative? At x equal to a would mean limit h tending to 0 f of a plus h minus f of a by h. This gives you some value, some finite value, and left hand derivative, that means this. Limit h tending to 0 f of a minus h minus f of a by minus h. Both of them are giving you a finite value. Finite value. This is limits, guys. If we understand the concepts of limits, this is easy to understand that if this thing is giving me a finite value, h is tending to 0, h is tending to 0, h is tending to 0, that means numerator should also tend to 0. Otherwise, how will you get a finite value? If your numerator gives you something not tending to 0, something not equal to 0, that means this will become infinite. This will become not defined. Correct? So your this part has to be, this part has to be equal to 0. This part equal to 0 means f of a plus h, f of a plus h should be equal to f of a. This numerator part equal to 0. Definitely it should be equal to 0. That means your f of a plus h should be equal to f of a. Because denominator is 0, no? And there is limits. And we know limit can only be defined. It will only have finite answer over here if both numerator and denominator are giving us a 0. Only denominator cannot give us a 0. Same thing will be applied over here. That means f of a minus h will also be equal to f of a, because both, this is also giving me a finite value. When this can give me a finite value, denominator is 0, numerator should also be 0. 0 by 0 format will be created, and then we can solve the limit and we'll get a finite answer. If both of these are finite, that means both of these are correct. F of a plus h is equal to f of a, f of a minus h is equal to f of a. That means a left hand limit, f of a plus h is what? Right hand limit. F of a minus h is what? Left hand limit. Left hand limit and right hand limit are both equal. That means, and are equal to f of a. That means my function is continuous at f of a, at x equal to a. What did we mean by continuity? Left hand limit, right hand limit, both are equal. We can put limit also over here, right? F left hand limit and right hand limit at a both are equal and are equal to f of a, then we can say function is continuous at x equal to a. So even if both LHD and RHD are not giving me a equal value, but they are giving me a finite value. Finite will be only possible if my f of a plus h is equal to f of a and f of a minus h is equal to f of a. In this case only I can say that I am getting a finite value, whatever values we are getting, but this is going to be hold true. Okay, let's move ahead. Let's do a question based on definition, right? Okay, find LHD and RHD at x equal to 0. Try it once. What will be the meaning of LHD? LHD would mean nothing but limit h tending to 0, correct? F of a plus h, f of a plus h minus f of a divided by h. This is what the definition says, correct? And here remember every time that your h is greater than 0. Your h is greater than 0. Where are you finding left hand limit? You are finding at 0. So LHD at 0, at x equal to 0. They are asking you at x equal to 0. So what will be your answer? This statement will become h tending to 0. Instead of a, you will put 0. So this is nothing but 0 plus h. Oh, we are finding LHD. Sorry. Let's do one thing. Let's write it RHD instead of changing minus h over here. We are finding RHD, right hand derivative, right? In left hand derivative, it will be minus h. Here it will be minus h. So first, pay attention at right hand derivative. Right hand derivative at 0. So instead of a, we'll put just 0. So it will become 0 plus h minus f of 0 divided by 0. Oh, sorry, divided by h. Here h only will come. Correct. Now h is positive. Correct. H is positive. So limit of h tending to 0, 0 plus h. That means greater than 0. This thing is going to give you greater than 0. F of here, where did f go? F of 0 plus h. F of 0 plus h means where will you receive that value from? Here. X is greater than equal to 0. So function will become x square plus 3. Function will become x square plus 3. That means what are we going to have? We'll have minus h square. Instead of x, we'll put h. Limit h tending to 0. So minus h square plus 3. Minus h square plus 3. This is what is going to come. Obviously limit h tending to 0. Limit h tending to 0. 0 plus h is positive. Positive means x is greater than this part will come, right? This part will come. When x is positive, we'll have the function will become minus x square plus 3. So now the function is positive. 0 plus h. H is positive, so this thing is going to be positive. Instead of x, we'll have to put h. F of h we are finding. H is positive. So minus h square plus 3. Here we'll have minus h square plus 3. Minus f of 0. At 0, what is the value? At 0 also this value. At 0 also, when x is 0, this value only. So minus 0 square plus 3. So here also plus 3. Welcome. Sorry, minus 3, right? F of 0 plus h minus f of 0. F of 0 will be equal to 3. Here there was a minus, right? Divided by h. So h. Okay. Plus 3 minus 3 became 0. Plus 3 minus 3 became 0. Correct. Minus h square by h will become minus h only. Limit h tending to 0. This entire thing will come out to be equal to 0. This entire thing will come out to be equal to 0. Now LHD, left hand limit, left hand derivative at x equal to 0. Can we put directly? Limit h tending to 0. Now what are we going to have according to definition? F of a minus h minus f of a divided by h. Minus h. Correct? Minus h. this is nothing but, instead of a we are going to have 0, because we are not finding at a, we are finding the left hand derivative at 0. So this will become limit h tending to 0, f of 0 minus h minus f of 0 divided by minus h. Okay, what are we going to have? 0 minus h. H is still positive. In this case also, h is positive only. In both the cases, h is positive. That means we are slightly less than 0. Right? 0 minus h will be slightly less than 0. Correct? So less than 0, the function will become e to the power x plus 2. E to the power x plus 2. What is x? 0 only. Sorry, instead of x, we'll put h now. What will this thing become? This will become limit h tending to 0, f of minus h minus f of 0 divided by minus h. So f of minus h, h is greater than 0, so minus h will be less than 0. Function will become e to the power h plus 2. This thing will become e to the power limit h tending to 0, e to the power of h plus 2 minus f of a. F of 0 will again be will be plus 3 only. So here it will be minus 3. F of 0 will be 3 only. So minus f of a will be minus 3 divided by minus h. So minus h. And here also there will be minus h, because we are doing f of minus h. Now this is the standard format. E to the power 0 minus 1 divided by same 0. Right? Limit of this will give you 1. Right, limit of x tending to 0, e to the power 0 minus 1 upon same 0 will give you equal to 1. Standard formats of limits. Here also we are getting standard format. Why? Because 2 minus 3 is going to become minus 1 only. So we'll have e to the power minus h minus 1 upon minus h. E to the power 0 minus 1 upon same 0. This is going to come equal to 1. Your left hand derivative is equal to 1. Your right hand derivative came out to be equal to 0. So your RHD is not equal to LHD. RHD not equal to LHD. So what can we say about it? This is non-differentiable. The function is non-differentiable over here. We can surely say that. LHD and RHD both 3. Why? Yeah, Daksh, no problem. It's okay. Hi, Supana. How are you? No problem. Whoever gets benefited, even if single students gets benefited, that's good for us. Okay. Maybe right now many of them are busy. Some of them are busy in preparations. Rest of them are busy in vacation. That can be the reason. That can be the only reason. Okay. Understood? RHD and LHD both are not equal. That means function is not differentiable at x equal to 0. RHD came 0, LHD came 1. Okay, very important function over here, x mod x. Many times application directly on this. You have to use the results of f of x equal to x into mod x being differentiable or non-differentiable. You'll have to directly use these results sometimes. Oh, one more question was there, kya? And this, no. At x equal to 0, we have to check. We have to check whether x mod x, f of x equal to x mod x is differentiable at x equal to 0 or not. Now, my function f of x, first of all, whenever you can define the function piecewise, define that, then only you will be able to have the feel of differentiability. If you can define your function piecewise, partwise, then you can approach towards commenting upon its differentiability very easily. If you cannot do that, then it will be difficult. Okay, so if my function f of x is x into mod x, if your x is positive, then mod x will open with plus sign. So x into x will become x square. Correct? X into x will become x square. If your x is positive, if x is greater than 0. Greater than or equal to 0 also, this thing only. Okay, if x is negative, what will happen if x is less than 0? If x is negative, then mod x will open with a negative sign. That means minus x. X into minus x it will become. So we'll have minus x square. Correct? Now, LHD and RHD, we have to comment upon LHD and RHD. That we can do very easily. LHD, left hand derivative at x equal to 0, will be f of 0 plus h minus f of h minus f of 0 divided by h. This will be RHD. Why am I making mistakes? This will be your right hand derivative. Correct? What will this be equal to? F of h. H is positive. Here h is positive. H is positive means we'll have x square. F of h will become h square. We'll have h square. H is positive, so 0 plus h will also be positive. When x is positive, function is x square. So h square minus f of 0. This is also going to give me at 0 also. Function at 0. F of 0 will be this thing only. H square minus 0 divided by h. H will get cancelled. Answer will be 0. Your RHD will be equal to 0. What will be your LHD? Left hand derivative. LHD means f of 0 minus h minus f of 0 divided by minus h. Great. 0 minus h. That means f of minus h. H is positive. So we'll have this function. H is positive. So minus h will be less than 0. That means function will be this. So what will be the value? Limit h tending to 0 minus h square minus f of 0 still will be 0 only. Minus h square minus 0 divided by minus h. Again, h will get cancelled. H is tending to 0. So answer will be equal to 0 only over here. LHD and RHD both are equal to 0. Option C will be your correct answer. Both LHD and RHD are equal to 0. Sir, abstract algebra एग्जाम का है 20 days पहले से कुछ नहीं. In TGT or I remember in TGT books, this will be given. There is 20 days पहले कैसे करें? Abstract algebra and linear algebra. Linear algebra is given well in the books for TGT. TGT books, if you go through there, you'll see linear algebra is very well given. So from the linear algebra, I don't think that will be very difficult if you have learned that very well in your college exams, college classes. Then otherwise, you have to refer some books. There are very rarely any videos about abstract algebra and linear algebra on the YouTube, but there will be some. Take help from there. 20 days are very much, too much in fact. I remember learning for college semester exams just before 2 or 3 days. And I remember everybody doing that. Nobody starts 20 days earlier. It's good that you have started 20 days earlier. If I'm reading correct what you're asking to, what you're saying. Both are equal to 0. Now this result is important such that just like x mod x is differentiable at x equal to 0. Left hand derivative and right hand derivative both were equal to each other. Right? Right hand derivative was 0, left hand derivative was 0 for x mod x. That means, and f of 0 was 0 only. F of 0 was 0 only. Correct? Both are finite, equal and equal to f dash of a. That means f dash of 0, that means the function x mod x is differentiable at x equal to 0. Similarly, the general case of this is like this. X minus a mod of x minus a will be definitely differentiable at x equal to a. We should remember this result as it is, because this is what I was talking about, shortcuts. General method will become very long if you keep on doing with a plus h minus f of a upon h or a minus h minus f of a upon minus h. many times you'll get confused and there are chances that you'll end up having a wrong answer. If you remember some important results, you can apply shortcuts, and very few important results are there in this chapter. So you will be able to apply shortcuts and your answers will be faster. Differentiability, continuity answers, sometimes it is observed that they can be obtained in merely seconds if you're thorough with the concept. So that will save your time and give you marks. +4 marks you are going to get if you can do it correctly. So remember, x minus a into mod. Now see, mod of x minus a, why is this happening? Mod of x minus a, it will create the problem at a only, at a, right? It will create the problem at a. For example, mod of x was creating the problem at 0, but this x multiplied with mod of x is making it smooth, right? Mod of x, you remember, right? Mod of x, mod of x is not continuous at x is equal to 0, right? It is, I'm sorry, it is continuous, but it is not differentiable. It is sharp at x equal to 0. This is how the graph is, correct? Mod x ka graph, mod x graph is like this. It is not differentiable at x equal to 0. Mod x is not, but because this x is being multiplied, it is changing the degree. This x is also becoming 0 at x equal to 0. This x is also becoming 0 over here. That is why there are two ways, right? There are two ways. Mod x was sharp at x equal to 0, but x mod x will not be sharp at x equal to 0. Okay, x mod x will not be sharp at x equal to 0. The degree will be changed and that will make it smooth. So remember, if you have mod of x minus a, the only problem is at a. Problem is at a. At a it won't be differentiable, correct? But because this x minus a is also becoming 0 at a, product of these two is going to give me a differentiable function. Remember it like this. Not just that x mod x will be differentiable at x equal to 0. Say that something inside the mod which is multiplied with something which is also becoming 0 at the same value where the mod is becoming 0, right? This product is also always going to give you a differentiable function at a. Remember it like this. Okay, understood, I hope. So remember it, x minus a, mod of x minus a will be differentiable at x equal to a, and x mod x will be differentiable at x equal to 0. Mod x is not differentiable at x equal to 0. Mod x graph, you remember, at x equal to 0 it is sharp, but x mod x, the degrees change, x is also becoming 0 outside. Here also x is becoming 0 at 0. That is why we are getting a smooth point now, correct? Becoming 0 is two ways possible, no? Like this something can become 0 and like this something can become 0. But this is differentiable, here non-differentiable. So the concept, I hope I was able to make clear to you that why x mod x is differentiable but mod x was not differentiable, and x mod x especially, this outside thing is becoming 0 at the same value where mod x, the value inside the mod is becoming 0. That is the main reason behind it. Okay, now shortcut, not shortcut basically. For example, over here only, over here, left hand derivative, why are we doing f of 0 minus h and f of a plus h or f of a minus h every time? Why do we have to do this every time?
ये सब बुक है शायद मेरी क्लास में पढ़ने वो एक बार शीट में क्रॉस चेक करने के लिए शायद.
Just a minute, guys.
कोई नहीं, you can just take it.
Okay, sorry, there was a there was some disturbance. Huh. I was saying that why are we every time for finding derivative, do we every time do a plus h minus f of a upon h? We don't do that, right? We remember the derivatives. So here also we could differentiate very easily. We could say 2x when x is greater than 0 and minus 2x when x is less than 0. We could say that, right? So left hand derivative, right hand derivative, we can easily also find using the standard derivatives. We know standard derivatives. If we know differentiation, then we don't have to do this every time. Correct? In class 11th, if they teach you this before differentiation, they'll teach you like this. Otherwise, you know the derivatives. So that's the shortcut. That's what we are talking about. That's what we are saying, shortcut. That you directly differentiate. Na? Why to bother yourself? For example, over here, check differentiability of f of x at x equal to minus 1. So what is your f dash x? What is f dash x? First, let's find f dash x. F dash x is going to be equal to 1 minus x square. Differentiation of it will be 0 minus 2x. So minus 2x. When x is less than 1. When x is greater than 1, that means this x is greater than when x is less than minus 1. When x is greater than minus 1, then 2x plus 2. That means 2x plus 2. So differentiation of 2x plus 2 will be equal to 2 only when x is greater than minus 1. Now, why did I remove the equality sign over here? See, we are directly finding the derivative. We are directly finding the derivative. Can we find the derivative at x equal to 1? No. Whenever we find the derivative, remember the definition. We do a plus h. We find the derivative when we have two close points. At the point we cannot find. Like that. Right? At the point we cannot comment upon f dash x. We cannot talk about f dash at x. We cannot talk about f dash x at x equal to 1. We need 2 points. So left and right, we can talk about greater than minus 1. We can talk about less than minus 1. At the point, how will we connect? How will we comment? By definition, there is no meaning of at the point, right? F dash x at 1, what will it mean? It can be for less than minus 1 or greater than minus 1, right? We need a plus h minus f of a upon h. By definition, we need 2 points, right? A and a plus h, correct? So whenever we'll apply this shortcut or this method, whenever we'll directly differentiate and check the left and right hand derivative, we'll remove the equality sign. We'll not include the equality sign in those cases. Now we can comment upon left hand and right hand derivative. Left hand derivative would mean f dash at minus 1 minus. Minus 1 minus means this will be your LHD. Left side of minus 1. Derivative at left of minus 1. So left of minus 1, that means less than minus 1. That means minus 2 into minus 1. Correct? Minus 2 into minus 1. Limit. Right? So x will be equal to minus 1. Minus 2 into minus 1 will give you 2. Right hand derivative. What is the meaning of right hand derivative according to this? F dash at minus 1 positive. That means f dash at a value slightly greater than minus 1. Slightly greater than minus 1, that means this. Already given to us equal to 2. So your LHD and RHD both are equal. That means function is differentiable at x equal to minus 1. F of x is differentiable at x equal to minus 1. You can directly comment upon it, right? So differentiable, both are equal to 2. Directly we found the LHD and RHD, and this is what we are going to do generally in exam also. Use this every time. We cannot keep on doing a plus h minus f of a upon h or left hand derivative like that. It's better that we can use the shortcut, although there are some limitations of this particular method also. We'll talk about it as the question comes, but you can apply like this, right? It must come to your mind that, sir, we know how to find the derivative, then why are we doing, right, a plus h minus a upon h every time, Right? We can. And one important thing, while applying this method, just remove the equality. You know why to do that? You cannot find derivative at x equal to -1. You can only find for x less than -1 and x greater than -1. Okay, let's see this question. Now, sometimes in differentiability and continuity, graph is going to give you the better idea of the question and going to help you to solve the question faster than the general approach. Most of the times this will happen. For example, over here, if we talk about x minus 1 into x minus 3, we know how the graph is going to be. It's a polynomial function, right? It is a polynomial function. It is a polynomial function. So 1 and 3, this is how it is, quadratic polynomial. This is how the graph is going to be for x minus 1 into x minus 3. Now what did they do? They applied mod over x minus 1 and x minus 3. So what are you going to do? You'll just remove this part. That's how we construct the graph of mod functions. You'll remove this part and this part will come like this. Correct? This is going to happen. So what does the graph say? Think about it. What does the graph say about differentiability? Polynomial function, forever continuous. Polynomial function, always continuous. But differentiability, we have to check. It is always differentiable except these two sharp points. It is always differentiable except these two sharp points. Check the continuity and differentiability at x equal to 1 and x equal to 3. It will be continuous at x equal to 1 and x equal to 3, but it won't be differentiable at x equal to 1 and x equal to 3. We can check with the method that we learned just now. That also we can use. For example, f of x. So now, if we talk about this function, mod of x minus 1 into x minus 3. Where all we'll have to check? At x equal to 1 we have to check, and x equal to 3 also we have to check. So if we want to define this function piecewise, how will we define? Before 1, after 3 and between 1 and 3. Right? Before 1, that means f of x will be defined in 3 pieces. Before 1, that means x less than 1. Correct? When x is less than 1, what will we have? Negative. So this entire thing will become positive. So mod will open with positive sign only. We'll have x square minus 4x plus 3. X square minus 4x plus 3 will be our function. When x is between 1 and 3, what will happen? X is between 1 and 3. X is greater than equal to 1, less than equal to 3. Right now I'm not applying the method. That's why I'm including equality. I'm defining the function piecewise, right, with respect to 1 and 3. So between 1 and 3, if x is between 1 and 3, let's say 2, so this will be negative, this will be positive, and mod will open with negative sign because the product will be negative. So mod will open with negative sign. What will it become? Minus x square plus 4x minus 3. Correct? And if x is greater than 3, this will be positive, this will be positive. So if x is greater than 3, then both will be positive. Mod will open with a positive sign, x square minus 4x plus 3. This is how, although bad in writing, pardon me for that, but believe me, I'm trying to improve. Okay, this is how you can define your function. Now you know how to apply your method. No need for LHD and RHD by doing f of a plus h minus f of a. That will be very long. Instead, we can directly find the derivatives over here. So f dash x, when x is less than 1, what will happen? When x is less than 1, your f dash x will be 2x minus 4. Derivative of this. Now, will not include the equalities. We are not going to find the derivative at x equal to 1 or x equal to 3. We'll talk about the extremes now. X is less than 3 and greater than 1. In that case, minus 2x plus 4. This will be your f dash x. And 2x minus 4 only when your x is greater than 3. So now what are they asking? They are asking you to check the differentiability at x equal to 1 and x equal to 3. So your f dash at 1 negative, f dash at 1 negative, at 1 if we are checking f dash at 1 negative, that means f dash at number slightly smaller than 1. Smaller than 1 means this. So f dash at minus 1 will be, f dash at 1 minus will be 2 minus 4, that means minus 2. And f dash at 1 positive, that means slightly greater than 1, that means over here, minus 2 plus 4, that means plus 2. Minus 2 and plus 2. LHD and RHD are not equal, not differentiable. We can see here also, although graphically we are able to see very easily, right? At 1 and 3, it is not differentiable. F dash of 3 plus, what will be f dash of 3 plus? Greater than 3, 2 x minus 4. So 2 plus 2. And what will be f dash of 3 minus? 3 minus means smaller than 3. What will be the derivative there? Here, f of 3 minus, that means slightly smaller than 3. So minus 2 into 3 plus 4. Minus 6 plus 4. It will be equal to minus 2. Again, LHD is not equal to RHD. So that means function is not differentiable at 1 and 3. We can directly comment upon it. Function is not differentiable at 1 and at 3. With graph, we'll be able to understand it more clearly, although. Okay, with graph, we are able to understand it more clearly. Plotting the graph was not difficult, right? You know, if you know how to plot this mod of x minus 1 into x minus 3, then here itself you can say at 1 and 3 it is not going to be differentiable. It will be continuous, but it is not going to be differentiable, right? There will be two sharp points at 1 and at 3. Rest everywhere it will be differentiable. Okay. How have they done it? They have also done it like this. Now, second variety, although same, this first checking the differentiability is much more important, but sometimes they'll tell you that it is differentiable and you have to find some variables or constants. Okay, you'll have to find some other values. They'll give you, just like in continuity, they gave you it is continuous. What will you apply? You'll apply RHL equal to LHL is equal to f of a. Here, if they're giving you it is differentiable, then you'll apply LHD equal to RHD equal to f dash of a. Correct? So, this time, some twisted question, like same concept, but this time they are asking you some values. By giving that, it is differentiable. Acha, if they are, see, here, I'll give you one hint of an important concept. Here, what we were doing here, we were checking that whether it is differentiable or not. So that is why we were removing this equality. Here we were checking, we were finding f dash x, but we were checking whether it is differentiable at 1 or 3 or not. If we knew that at 1 and 3 it is differentiable, here it is not, but suppose if we knew that it is differentiable at 1 or 3, then we can include the equality also. Why are we not including? Because at f of 1 and f of 3, we cannot comment upon the derivative. But if it is given to us that it is differentiable at 1 and 3 also, then we can include the equality also, right? Right or not? In that case, we can include the equality. There is no problem in that. So remember this concept. Now, let's see this question. Fx is differentiable. It is differentiable at x equal to 1. The function is differentiable at x equal to 1. What I just said need not to be thought a lot, need not to be, don't get yourself confused with that. Generally, whenever you are applying the shortcut, directly finding the derivative for LHD and RHD, do not include the equality. You'll always get the answer. Don't worry about it. I'm saying it is differentiable at x equal to 1, then find a and b at x equal to 1. If it is differentiable at x equal to 1, then simply what we'll do, we'll find LHD and RHD at x equal to 1 and we'll put it equal to f dash of 1. No, here it's not going to work. How will that work? You tell me, how will you find LHD and RHD at, if you'll find LHD and RHD at 1 also, you'll equate it, how will you get the equations? How will you get the equations? Think about it. What should you do? You can put, suppose if you check this, suppose if we apply only differentiability, let's say we check the differentiability at x equal to 1. Okay, let's say we check the differentiability at x equal to 1. What we'll do, we'll find f dash x, and we'll define it for, we'll define it for x greater than 1 and x less than 1. Okay, x greater than 1, let me write x less than 1 here and x greater than 1 here. Now for x less than 1, what will be your f dash x? 4x plus 5, right? 4x plus 5 will be your derivative of the function for x greater than, for x less than 1. For x greater than 1, b, only b, right? What will be the derivative of this function? Only b, correct? Now you say that, okay, 4x plus 5 left hand derivative at 1, that means f of 1 minus is equal to f dash of 1 minus is equal to f dash of 1 plus. This is what your definition of differentiability says. So this is what you're going to do. F dash of 1 minus, that means this thing, 4 into 1 plus 5, that means 9. F dash of 1 plus function f dash x will become this, that means only b. So your 9 is equal to b. But how will you find a? One value you got, b you got with differentiability, but how will you find a? So whenever these type of questions come where you have to find values and you need to generate equations, one more equation you can generate, that if it is differentiable, definitely it is continuous. If it is differentiable at x equal to 1, definitely it is continuous at x equal to 1. That means left hand limit and right hand limit are going to be equal. Left hand limit, LHL at x equal to 1, 2 into 1 plus 5, that's it. How will you check the continuity at x equal to 1? 2 into 1 plus 5 at x equal to 1. When LHL, what will be LHL? What will you do? LHL is equal to RHL if it is continuous. Correct? So left hand limit for x less than 1, that means 2 into this value, 2 into 1 plus 5 into 1 plus a, that means 7 plus a. Right hand limit for x, right hand limit means x should be greater than 1. Right hand limit at 1, x should be greater than 1, that means this value, b into 1 plus 3, that means b plus 3. You already have b. So your a will come out to be 9 plus 3, 12, 12 minus 7, 5. Now you got a and b both. A equal to 5, b equal to 9. I think this should be the answer. Wait. A equal to 5, b equal to 9 only should be the answer here. See, I hope we didn't do any calculation mistake. Although I don't think so, but how a 7, 5 plus 4, 9 only, no? Okay, b is 9, pakka. If b is 9, 9 minus, if b is 9, this is wrong, right? A is 5. Maybe solution is, there is some fault in the solution. Correct, we found the correct answer. A is 5, b is equal to 9. So here it's given also. Here it was not, but here it's given. A is equal to 5, b equal to 9 is correct. All right. Now let's see over here. Some horrible looking functions, but does not matter. Okay, give it a thought. Give it a thought. Okay, here this thing, what will this thing mean? I'll write down this thing. What does this mean? Mod of x greater than equal to 1 it means x is either less than equal to -1 or x is greater than equal to, x is less than equal to 1 or x is greater than equal to 1. Just a minute. Haji, this thing mod of x greater than equal to 1. If we are saying mod of x greater than 1, what does it mean? X is between 1 and -1. Correct? That's what is written over here. Mod of x is greater than equal to, is greater than equal to 1. So either your x, I wrote ulta. Mod of x, if your mod of x is less than 1, x is between 1 and -1. Correct? If mod of x is greater than 1 means mod of x is less than -1 and mod of x is greater than 1. This would mean mod of x is less than -1 and mod of x is greater than 1. Equal to will also come. Let me write it more neatly. Otherwise you'll say that, sir, your handwriting only is bothering us. This would just mean mod of x is less than equal to -1 or mod of x is greater than equal to 1. This is what it will mean. Mod of x less than 1 would mean this, so you know, this would mean x, this would mean, oh here why did I include mod? X is less than equal to -1 or x is greater than equal to 1. Okay, here it will mean x is less than 1 and greater than -1. Right, if we can decode this, then there is no problem. Point, it is differentiable at every point of domain, then find the values of a and b. Give it a thought. If it is differentiable at every point of domain, then find the values of a and b. We know two things. Differentiability, we have to, whenever this type of question comes, when you are given that it is differentiable and you are finding the values of some constants, you have to use both continuity as well as differentiability. So without even thinking, first use continuity at x equal to 1. Check continuity at x equal to 1. If it is continuous everywhere, it is going to be continuous at 1 also. So we'll check the continuity at x equal to 1. Continuity at x equal to 1. When LHL, what will be LHL? LHL means, RHL. RHL means x is greater than 1. Greater than 1, what will be the value? 1 by 1. That means 1. RHL equal to LHL, we are going to apply over here. So this will give us, RHL will give us 1. LHL, that means x is less than 1. X is less than 1. When x is less than 1, what is happening? When x is less than 1, we are checking continuity at 1, not -1. When x is less than 1, what is happening? This thing, a plus b. So 1 will be equal to a plus b. Then we can also check the continuity at x equal to -1. Right? We can check at both the points. At x equal to 1 also we can check. At x equal to -1 also we can check. Because we have those kind of values. At x equal to -1, RHL, what will be RHL? Again do RHL equal to LHL. Because continuous at x equal to -1 also. It is differentiable at every point in domain. Continuous at every point in domain. So at x equal to -1 also it should be continuous. At x equal to -1, when the value is greater than -1, what is the function? A plus b. RHL will be a plus b greater than -1. So value will be a plus b. When LHL, that means when function is less than -1. Less than -1, that means this value 1 by mod of x, that means 1 by mod of -1, again 1. So same thing we are getting. Okay, same thing we are getting. So it's not useful. This thing is not going to be giving us anything. right? Continuity at x equal to 1 and continuity at x equal to minus 1, giving us the same equation, 1 is equal to a plus b. So not useful. Definitely now we'll have to use the differentiability. We'll have to take account of differentiability. So what we'll do, we'll check differentiability at x equal to 1. We'll check differentiability at x equal to 1. Right hand derivative, left hand derivative at x equal to 1. Correct. Right hand derivative at x equal to 1 will give you what? When function is greater than right hand derivative, what will right hand derivative become? When function is greater than 1. Greater than 1, that means 1 by mod x will be 1 by x only. Differentiation of 1 by x will be equal to minus 1 by x square. Minus 1 by x square at 1 will become minus 1 only. Correct? This will become minus 1 only. Left hand derivative, LHD at 1. Left hand derivative at 1. That means differentiation of function when x is less than 1. Less than 1 means this thing. 2a plus 0. 2a plus 0. So left hand derivative at 1 will be 2a plus 0. 2 into 1 plus 0. 2 into a plus 0. 2ax plus 0. It will become 2ax plus b. But at 1 it will become 2a plus 0. That means 2a only. Right? Left hand derivative. Derivative when x is less than 1. What will be the derivative? Which function will use? This function. Derivative of this will be 2ax plus 0. That means 2a. 2ax. At x equal to 1 it will become 2a. So these two are going to be equal. That means my 2a will be equal to minus 1. I got one value. 2a is equal to minus 1 gives me a equal to minus 1 by 2. And if a is equal to minus 1 by 2, then from here I'll get b is equal to a is minus 1 by 2. 1 plus 1 by 2, 3 by 2. Correct? So minus 1 by 2 and 3 by 2. B will come out to be 3 by 2. So continuity and differentiability both I have to use, and I have to use quicker. Right? We cannot keep on doing f of a plus h minus f of a upon h. We can directly find the derivative. See, right hand derivative at x equal to 1. Right hand derivative at x equal to 1. That means first find the derivative when the value of x is greater than 1. When the value of x is greater than 1, that means your function is this. Derivative of this is minus 1 by x square. Correct? Greater than 1. So 1 by x ka derivative is minus 1 by x square, and putting x as 1 over here gives us minus 1. Left hand derivative. That means find the derivative of the function when x is less than 1. X is less than 1, function will be this. Derivative of this will be 2ax plus b. 2ax plus 0. 2ax plus 0. Here it is 0, right? Why am I writing b? Right? 2ax. Correct? Now x equal to 1. Left hand derivative at 1. So x equal to 1 gives us 2a equal to minus 1. Left hand derivative gives us 2a. And then left hand derivative, right hand derivative both should be equal, because it is differentiable at x equal to 1 also. That means 2a should be equal to minus 1. Eventually we got a equal to minus 1 by 2. And from here we get b is equal to 3 by 2. That's how we could get the answer very easily. Again, similar type of question, just a little bit different face of it, or just by including pi and cos and all, maybe they try to make it a little more confusing, but there is nothing confusing about it. Okay, give it a thought. Give it a thought once. k1 into x minus pi whole square minus 1 when x is less than pi, and when x is greater than pi, k2 cos x, like this. This is differentiable. Now in this part, I was saying one thing earlier. In these type of questions, when they are giving you differentiable already, right, while writing LHD and RHD also, you can include the equality, because they are giving you that it is differentiable everywhere. And here one term is used, it is twice differentiable. Twice differentiable means f double dash x. Twice differentiable means nothing but f double dash x. if the function is twice differentiable, then ordered pair k1 and k2. And here they did not give differentiable where, at what point. So that you have to understand by the question they are talking. We can check at pi only, right? We can check at pi. They did not give where it is differentiable, at which point it is differentiable. So obviously you'll have to understand that they are talking about x being equal to pi. So first you will do continuity, check continuity at x equal to pi. Continuity at x equal to pi. Okay. So when x is equal to pi, LHL, when x is less than pi, LHL, that means left hand limit, slightly less than pi. What we will get there? Pi minus pi into k, 0 into k, 0, minus 1. LHL will become, so LHL will become minus 1. Correct? Pi into pi, 0 into k1, 0, minus 1. Here there is a minus 1, so minus 1 will come. RHL, what will be RHL? Right hand limit. Right hand limit for at x equal to pi. So slightly greater than pi. Slightly greater than pi, that means function will be this thing. Cos pi is minus 1. Cos pi is minus 1. Cos pi into k2 will become minus k2. So RHL will become minus k2. So your minus 1 is equal to minus k2. That means k2 is equal to 1. This is what you are getting from continuity by using continuity. But you need k1 and k2 both. You did not get k1 by using continuity. So you'll use differentiability. But of course, differentiability says that your f dash x, first find f dash x. For f dash x also will be piecewise defined when x is less than pi. Now here remove that equality as we have learned generally. When x is less than pi, what will be your differentiation? 2 into k1 into x minus pi minus 0. So 2 k1 into x minus pi. This will be your function when x is less than pi. Differentiation of this will be 2 into k1 into x minus pi. When x is greater than pi, what will be your function? This, and differentiation of this, cos ka differentiation will become minus sign. So k2 into minus k2 into sine of x. It is twice differentiable. Twice differentiable means it can be differentiated again, and there also LHD and RHD will exist. So differentiate it again. F double dash x, find f double dash x. Now for x less than pi, differentiation of f dash x. So differentiation of this, 2k1 into x minus 2k1 into pi. 2k1 into pi will be constant. Differentiation of 2k1 into x will be 2k1 only, right? So 2k1. Correct? When x is greater than pi, differentiation of this will become minus k2 cos x. Sin x will become cos x. So minus k2 cos of x. Correct? So k2 is not equal to 1 for sure. Now we have to comment upon k1. Piecewise differentiable. We have it is twice differentiable. That means for this RHD and LHD will be equal and finite, right? What will be LHD? LHD, when x is less than pi, function is 2k1. Correct? LHD at pi. We are checking differentiability at x equal to pi. So this is your LHD, left hand derivative, right? Will be equal to your right hand derivative, double derivative. Here twice differentiable, so we can check over here also. 2k1, right hand derivative when x is greater than pi, x cos pi will become minus 1, and minus 1 into minus k2 will become equal to k2. So 2k1, left hand derivative will be equal to right hand derivative, 2k1 equal to k2, and k2 equal to 1. So k1 will be equal to 1 by 2. 1 by 2 comma 1 will be your answer. 1 by 2 comma 1 will be your answer. And anyway, when we got k2 equal to 1, this option and this option anyway got rejected. Hello Anup, how are you? Understood? Two options anyway got rejected, so you have to stepwise check. Use continuity as well as the differentiability. Don't be in a hurry. This is the correct approach of solving the questions of differentiability. Now, what is written? Shortcut does not work always. There are few exceptions. There are two cases where you should not use shortcuts. Correct. Shortcut actually you cannot use when the function is not even continuous. Suppose you are checking, you are applying the shortcut at x equal to a. You found f dash a, right? You found f dash x. Now at x equal to a, you are applying the shortcut. At x equal to a, you are finding LHD and RHD. You directly differentiated, applied the shortcut. But suppose at x equal to a, the function is not even continuous. Then how can you talk about differentiability? If function is not continuous, then it is definitely not differentiable. Correct? And sir, but if it is not continuous, then we'll get different LHD and RHD. This must come to your mind that if it is not continuous, then RHD and LHD will come different. That means not differentiable also. Sometimes it will not happen. For example, suppose your function is somewhat like this. Not this. Something like this. Now left hand derivative. This is your x equal to a, suppose. This is your x equal to a. Left hand derivative if you find, it will come like this. Right hand derivative if you find, it will come like this. Both slope is same. So here left hand derivative, right hand derivative will give you a value. But the function is not continuous. If it is not continuous, then at x equal to a, it is not even differentiable. That's the limitation of the shortcut. Okay, let's see a question related to that. Let's see some questions related to that. For example, over here. Now see, check continuity before applying shortcut. Shortcut may give wrong conclusion in case of discontinuous function. So always before applying the shortcut, shortcut means directly finding the derivatives and then finding LHD and RHD. Okay, at that point. That is what they are calling shortcut. Although it is not shortcut, it is correct method only, but sometimes you have to be careful while applying that method. Why? Because over here if you see, in A, if you see, if you find f dash x, right, when x is greater than 2, what is your f dash x? 3x square, right, 3x square will be your f dash x. And when x is less than 2, 6x will be your f dash x. Now what is your LHD? Left hand derivative at 2, LHD at 2, that means 6x. 6 into 2, that means 12. What is your RHD? At x equal to 2. RHD means right hand derivative. So when x is greater than 2, 3x square. 3x square at 2, that means 4 into 3. This is also coming equal to 12. Both LHD and RHD are coming equal to 12. But you see, this function is not even continuous at x equal to 2. When x is greater than 2, this will be the function. That means 8 plus 3, 12. When x is less than 2, this will be the function. That means 3 into 4, 12 minus 2, 10. Right? Here LHL is equal to 10 and your RHL at x equal to 2 is equal to 11. 8, 9, 10, 11, yeah, is equal to 11. So can we say, sir, how can I practice questions? Practice from Cengage, practice from modules, practice from sample questions, sample papers, Anup, right? There are a lot of questions. Go on Google, type sample papers of JEE 2024, 2025. You'll see a lot of questions. Many websites are there, right? Again, there also first learn the concept, try not to see the solution. If you are not able to solve for a longer time, then see the solution. Don't directly see the solution. LHL at 2, RHL at 2. RHL is 11, LHL is 10. Function is not even continuous. Can you see that? At 2, can you see? At 2, function is not continuous. Right hand limit at 2, that means slightly greater than 2, will give you 2 cube plus 3, 11. Left hand limit, that means x less than 2, slightly less than 2, so 3 into this function will come, 4 into 3 minus 2, 10. LHL and RHL at 2 are different. That means it's not continuous at 2. If it is not continuous at 2, how can it be differentiable at 2? Even if LHD and RHD are coming equal, Why? Because we applied shortcut. We directly differentiated it and checked the LHD and RHD. So before applying the shortcut, always check the continuity, and checking the continuity by now, you can do it very fast. Just like here. Directly we can check the continuity. So quickly check the continuity at that point and then apply your short method, directly finding the derivatives. That's what I'm talking about. Right? This can happen. No, some graph can be like this. It can be like this. From here it is breaking and here it is going like this. So here derivative and here derivative are same, but the graph is broken. It is not even continuous. Right? How can it be differentiable at that point? But at that point, your LHD and RHD might come equal sometimes, even if it is not continuous. It is not shortcut, it is defined method. But why it will go wrong? Because if it is not continuous, sometimes it is possible that LHD and RHD might come equal. So, not differentiable. Not differentiable. If it is not continuous, that means, what's this? That means it is not differentiable at x equal, not continuous, that means definitely not continuous at x equal to 2. Okay. Second point is that we cannot use shortcut if the function is defined separately at x equal to a. That means sometimes it will be defined for x not equal to 0, there is some function, and for x is equal to 0, the function is different. Right? Sometimes we sometimes they define the function like this. No, for x not equal to 0, the function is something, and for x equal to 0, function is something else. So in that case also, we cannot apply the shortcut directly. For example, the second B part was like this only. In this case also, we cannot apply the shortcut directly when the function is defined like this. When it is defined with greater than, lesser than, x greater than something at x less than something, then we can apply the shortcut directly. In this case, we should not apply the shortcut. We should check properly for differentiability. Right? For example, if I start doing f dash x, right? Suppose if I directly find f dash x, right? For x equal to 0, function is 0. For x not equal to 0, I'll have some derivative of this x square sine 1 by x. So it will be x square cos 1 by x into minus 1 by x square. First derivative, this as it is, derivative of this x square cos 1 by x into minus 1 by x square. This as it is, derivated this, and inside 1 by x derivation also will be minus 1 by x square plus sine 1 by x as it is, sine 1 by x as it is, and derivation of x square, that means 2x. That means 2x. Doing this will be completely wrong. This is for x not equal to 0. And then I start finding LHD and RHD. No, because LHD and RHD will be same at 0. Left hand derivative will also be this. Right hand derivative will also be this. Both will be equal only. What is the point of applying LHD and RHD? They both will be equal in this case. Correct or not? Getting my point? LHD and RHD both will be equal in this case. Try to understand. Just a minute, please. So how will we check? Right? LHD, by differentiating it, we cannot check. We'll use the normal approach that we know. Right? A plus h minus f of a upon that thing. Right? So simply just do at x is equal to 0, what will be your LHD? LHD will be limit by definition h tending to 0, f of 0 plus h minus f of 0. This will become f of 0 plus h minus f of 0 divided by f of h, divided by h. Correct? Divided by h. Correct thing? Getting my point, what I'm trying to say? Why are we not able to apply the shortcut? This should be very, very clear. Otherwise, this mistake definitely the students do, that they apply the shortcut in this case also. And they say it is differentiable. It may or it might not be. We cannot comment like that. We have to check with the normal approach. So what will this become? 0 plus h. So it will become h square sine of 1 by h minus 0. This will become h square sine of, oh sorry, wait, limit h tending to 0, h square sine of 1 by h minus f of 0. F of 0 means 0 only. When x is 0, function is 0 only, minus 0 upon minus h. Minus 0 upon h. This is your RHD. No, sorry. This is your RHD. We wrote RHD. This is your right hand derivative. Sir, no audio. No audio? I'm not audible? How is this possible? Wait. Ax plus 0. It will become 2ax plus b. But at 1... Syed Roshan, check your earphones. Right, left hand derivative when x equal to 1. Voice is there, man. Audio is there. Syed Roshan. Check. Let me check once again. Audio is there. Okay. This is going to be a right hand derivative h square sine 1 by h minus 0 upon h. Correct? When h is tending to 0, what will this become? What will this become? This will become equal to 0, standard. Correct? This will become h sine 1 by h. So will become equal to 0. H will be equal to 0, no? So sine 1 by h, whatever it is between 0 and minus 1 and 1, answer will come out to be 0. So now you can check LHD. What will be your LHD? LHD will give you limit h tending to 0, f of 0 minus h up minus f of 0 upon minus h. What will this give you? This will give you minus h square sine of 1 by h is positive only. So 0 minus h sine of 1 by h. 0 minus h, that means slightly less than, something other than 0. Something other than 0, same thing will come, minus h square. Here we'll get sine of 1 by h only, minus 0 divided by minus h, divided by minus h. Again, minus minus will get cancelled, h will cancel 1h. So h into sine of 1 by h will come, again it will also come 0. So in this case your LHD and RHD are coming equal. RHD is equal to LHD. In this case it is there. Right, RHD is equal to LHD. So this function is differentiable at x is equal to 0. We can say f of x is differentiable at x equal to 0. But we could not apply the shortcut in these cases. In this case it came out to be equal, but applying the shortcut is not advisable. Now here you can also learn one more thing. This is a standard thing. This is something which is used many times in JEE. So this is, remember this function, whenever x is raised to some n, right, x raised to n sine 1 by x, right, x is raised to n and there is sine 1 by x, right, and when x is not equal to 0, this is the case, and when x is equal to 0, your function is 0. This is a common function, general function. It is always different. It is never, sorry, it is, write it down over here. It is not continuous. It is never going to be continuous when your n, the power of x over here, is less than 1. If your n is less than 1, then this is not continuous. That means not differentiable, right? So it is neither continuous nor differentiable when n is less than 1. This power of x is less than 1. When n is equal to 1, when n is equal to 1, whenever n is equal to 1, this is continuous. When n is equal to 1, it is continuous. Remember it as it is. When n is greater than 1, it is differentiable also. When your n is greater than 1, it is also differentiable. Okay, this function as it is, this picture you can remember, and it will help you solve the questions very faster. Okay, whenever it is greater than 2, when n is even greater than 2, not equal but greater than 2, it will be even f dash x. That means it is the f dash x will also be differentiable. Here fx, here we are talking about f of x. Here we are talking about f of x. If n is greater than 2, then f dash x will also be differentiable. Although this must be written somewhere ahead, but remember it as it is. Okay. Now, let's see. It is not written. Let f of x be this. F of x is continuous at x is equal to 0 for p greater than 0. If p is greater than 0, then f of x is continuous at x is equal to 0. If p is greater than 1, then f of x is differentiable at x is equal to 0. This is what I wrote, right? Right, continuous and differentiable. F of x is differentiable at x is equal to 0 for p greater than 1. If p is equal to 1, then it is continuous. If p is greater than 1, then it is even differentiable. Okay, and one more thing you can write over here. F dash x is differentiable at x equal to 0 for p greater than 2. If p is even greater than 2, then f dash x will also be differentiable. F dash x will also be differentiable. Saidroshan, beta, I've said them so many times. I don't know why this is happening. I've even had a small argument on this, but even I don't understand why is this taking time. Maybe the files are not appropriate or something. I've checked, I've applied for this also once again, I've mailed for this also. It should come soon, right? Don't think that I don't know or I forget this. I don't forget this. I remember this. I'm talking to the team on this. Something has happened. Because of that, it's not being uploaded on this channel. For some of my videos, the notes are not there. Some of them are there. But I'll get this sorted as soon as possible. Don't worry about it. Okay. For example, this question can be solved very easily. Same thing, right? X, same function. So this function only, very common, generally used. Remember this function. X to the power n sine of 1 by x. Right? It is always continuous for p greater than 0. It is differentiable for p greater than 1. Just remember this part also, that is good. If p is greater than 2, then f dash x will also be differentiable. So see, fx is this. Here what is p? P is 2. P is exactly 2, not greater than 2. So what we can say, p is greater than 1. So it is differentiable at x is equal to 0. It is differentiable at x is equal to 0. F is continuous. If it is differentiable, then continuous also. F is continuous at x is equal to 0. Can we say that? Okay, wait. Here I think here only write continuous. Here only write continuous. F dash x is also continuous. We don't comment. Let's not comment upon its differentiability. It is continuous. Okay. So if p is greater than 2, then f dash x is continuous. That we can say. Then f dash x is continuous. Now over here, what is your p? Directly see. What is p? P is exactly equal to 2, not greater than 2. 2 is greater than 1. So that means f is continuous at x is equal to 0. F is continuous. F and f dash both are continuous. F is continuous but not differentiable. F dash is continuous but not differentiable. See, this is wrong because f is continuous and differentiable both when p is greater than 1. So this is wrong. Now about f and f dash. F dash will be continuous if p is greater than 2. It is not greater than 2. F dash will be continuous if p is greater than 2. But p is not greater than 2. So f dash is not continuous. This is also wrong. F dash is continuous but not differentiable. This is also wrong. Right? F dash is not continuous only. F is continuous but f dash is not continuous. F dash is not continuous because p is not greater than 2. F is continuous, definitely continuous. It's differentiable as well as continuous. So this is correct. You can directly mark using this particular result. Such questions you'll be able to directly mark. Otherwise, we can check like this also. Right? Right hand limit, left hand limit, right hand derivative, left hand derivative, entire bachda you have to do. But instead remember this result because this is a common type of question which is used. This common type of function which is used in the questions of differentiability and continuity. Now see, if what is written, I'll explain this. If f of x is a function which is differentiable and g of x is a function which is also differentiable. If I add or subtract these two functions, whatever I'm getting is definitely differentiable. I'll repeat, f of x is differentiable, g of x is differentiable. Adding them or subtracting them, same thing only, will give me a differentiable function. Agreed? Okay. Now most important part, the second point is most important. If f of x is differentiable at x equal to a and g of x is not differentiable at x equal to a, then the sum of these two is always going to be non-differentiable at x equal to a. Nothing can be said about their product and division. Right? About their product and division, we cannot say if f of x is differentiable, g of x is not differentiable or vice versa. We cannot comment upon their product, but we can comment upon their addition and subtraction. If any one of those is non-differentiable and one of those is differentiable, then sum of these two functions will definitely give us a non-differentiable function at x equal to a. If f of x is differentiable at x equal to a and g of x is also differentiable at x equal to a, adding them up will give me a function which is differentiable at x equal to a. Second point, if f of x is differentiable at x equal to a but g of x is not differentiable at x equal to a, adding them or subtracting them will give me a function which is definitely non-differentiable at x equal to a. Remember this. Okay, direct result will be used sometimes. I think, for example, over here only. Which of the following function is differentiable at x equal to 0? Acha, cos of mod x. What is cos of mod x? Cos of mod x is nothing but cos x only. X is positive or negative? In any case, it will be cos x only. Right? Cos of minus x is also cos x. Cos of plus x is also cos x. So, cos of mod x will be nothing but cos x. And cos x is always differentiable. Correct? Always differentiable, smooth. You know, cos of x ka graph, it's always differentiable. Cos x is always differentiable. Mod x is not differentiable at x is equal to 0. Mod x, right? Mod x. Remember, at x is equal to 0, it will be sharp. So, at x equal to 0, it is non-differentiable. Correct? Cos x is always differentiable and non-differentiable. So this is not going to be differentiable. Differentiable function plus non-differentiable function will give me a non-differentiable function. Which of the following function, they are asking about which of the following are differentiable. So this is non-differentiable. This is also non-differentiable. Addition or subtraction of differentiable and non-differentiable function will give me a non-differentiable function only. So this is also non-differentiable. What about this? What about this? This I'll have to check, right? Sine of mod x Sine of mod x can be sin x or minus sin x depending upon the value of x. So we'll have to check this near 0. We'll have to check this near 0, correct or not? So when my x is greater than 0, option C, if I'm checking, if my x is greater than 0, my function will become, if my x is greater than 0, my function, this will be my f of x. When my x is greater than 0, function will be sin x plus x, correct? Function will be sin x plus x, mod will open with positive sign. When my function is less than 0, when my x is less than 0, if my x is greater than, here I can use equal to because I'm only defining f of x. If x is less than 0, what will be the function? Sine of minus x. Sine of, mod will open with minus sign, so sine of minus x will become minus sin x. I'll get minus sin x minus x when x is less than 0. Now I'll find f dash. Acha, before that, before applying the shortcut, I'll have to check whether it is continuous at x is equal to 0 or not. Right side of x is equal to 0, value is sin x plus x. Sine of 0 plus 0, 0. Left side of 0, value is sine of 0 minus 0, 0. Continuous at x equal to 0. Correct? This is how I'll check now. Sine of 0 plus 0, 0 only. Sine of minus sine of 0 into minus 0 will be also 0. So it is continuous at x is equal to a. I can apply the shortcut now. F dash x I'll directly find. When x is greater than, now remove the equality because I'm applying the shortcut. X greater than 0, sin x plus x will become cos x plus 1. Differentiation of sin x will become cos x will become 1. When x is less than 0, minus cos x minus 1. This will become minus cos x minus 1. Correct? Now check LHD and RHD. Now you tell me LHD and RHD. At 0 plus and 0 minus, f of 0 plus, f dash of 0 plus and f dash of 0 minus. What will be f dash of 0 plus? F dash of 0 plus, cos of 0 plus 1. That means 1 plus 1, 2. F dash of 0 minus, minus cos of 0 minus 1. Minus 1 minus 1. That means minus 2. It is discontinuous. It is not differentiable. It is not differentiable. LHD and RHD both are different. Both are not equal. That means it is not differentiable. Although I can directly mark this, right? But even if you don't want to mark it, just see here plus x was there. So this will become cos x plus cos x minus 1. This will become minus cos x minus 1. This will remain minus cos x minus 1 only. Correct? Right? Fourth one will be the correct answer. There must be sine of mod x minus x. Now remember this. Remember this. Okay, I'll write it down somewhere. Sine of mod x plus x is not differentiable at x equal to 0, but sine of mod x minus x is differentiable at x equal to 0. Right? You can check this by finding with the complete method also. Find RHD, LHD, and you can apply the shortcut also. No problem. Right? But we proved that sine of mod x plus x will not be differentiable at x equal to 0. And definitely sine of mod x minus x will be differentiable at x equal to 0. Now remember this as a result. Remember this also as a result. Will be fruitful for you if you can remember this particular thing as a result. Sine of mod x plus x is not differentiable for x at x equal to 0. And sine of mod x minus x is definitely differentiable at x equal to 0. Okay. Which of the following functions is or are not, no, only is, that means single, correct, is not differentiable at x equal to 1. Is not differentiable at x 1. Now see, this particular thing, x square minus 1 into mod of x minus 1 into x minus 2. So this thing, what will this become? F of x, let me write it, x minus 1 into x plus 1 multiplied with mod of x minus 1 into mod of x minus 2. Now see, x minus 1 into mod of x minus 1, x minus a into mod of x minus a is differentiable at x equal to, right? Only 1 and 2 will create the problem. No, otherwise it is always differentiable. Polynomial function. Polynomial function we are getting. Basically we are getting polynomial function only. It will be always differentiable. Only 1 and 2 will be the points where I'll have to check for differentiability. Yes or no? Are you getting my point? Only at 1 and 2 I'll have to check for differentiability. But at 1, they are only talking about 1. At 1, this particular thing, x minus 1 and mod of x minus 1 will be differentiable at x equal to 1 according to this result. In the starting we saw x mod x is differentiable at x is equal to 0, x minus a mod of x minus a will be differentiable at x is equal to a. So x minus 1 into mod of x minus 1 will be definitely differentiable at x is equal to 1. And there is nothing to create a 0 for x minus 2. This will be differentiable at x minus 1, but there is nothing to create a 0 for x minus. This will be non-differentiable at x is equal to 2. And there is nothing which is making it 0, right? X plus 1 will not be 0 at x equal to 2. X minus 1 will also not be 0 at x is equal to 2. So there is nothing to make this portion equal to 0. Correct? So this will be differentiable at x is equal to 1. But this entire thing will not be differentiable at x is equal to 1 because of this. Oh, sorry, I'm saying this will be differentiable at x is equal to 1. X is equal to 2 will be a problem, but they are only talking about x is equal to 1. So this is definitely going to be differentiable at x is equal to 2. This is definitely going to be differentiable at x is equal to 1 because of x minus 1 into mod of x minus 1. Correct? This thing. And mod of x minus 2 will not be differentiable at x is equal to 2. And here nothing is there to make it 0 at x is equal to 2. So we can say this entire function is differentiable at x is equal to 1. We don't know about x is equal to 2. But they are asking about not differentiable. So this is not our answer. This is differentiable at x is equal to 1. Right? This one, just now we saw sine of mod x minus mod of x is differentiable at x is equal to 0. Just now we saw, right? Last question. Sine of mod x plus mod of x. Here I did not include mod, here also include mod. Sine of mod x plus mod of x is not differentiable at x is equal to 0. But sine of mod x minus mod of x is differentiable at x is equal to 0. Similarly, I can say sine of mod x minus a minus mod of x minus a is differentiable at x equal to a. Same generalized result. Sine of mod x minus a minus sine of minus mod of x minus a will be differentiable at x is equal to a. So this thing, sine of mod x minus 1 minus mod of x minus 1 will be differentiable at x equal to 1. So this is also not my answer because I want non-differentiable. I want non-differentiable. Correct? So I'll have to check for the third option. Now third, I don't have any general result. Third one, I don't have any general result. So what will I do? I'll check the function near 1. So my function near 1, wait, f of x, I'll have to define the function near 1. When my x is greater than or equal to 1, when my x is greater than or equal to 1, this will be opened with positive sign. Tan of x minus 1 will be positive, so it will become tan of x minus 1. This will be x minus 1. So I can say tan x minus 1 plus x minus 1. No problem. Both will open with positive sign. If x is less than 1, then this will open with a negative sign. This internal part will be negative. Tan of minus x is minus tan x. So minus tan of x minus 1. This will also open with negative sign. So 1 minus x, it will become plus 1 minus x. Correct. It is continuous near 1. Let's check. For greater than 1, 0 plus 0. Okay. 0 plus 1 minus 1, 0. Continuous. Right. LHL and RHL are equal. So I can apply my shortcut. F dash x I'll check. F dash x when x is greater than 1 and x is less than 1. Right, what will be my f dash x for x greater than 1 and x less than 1? So when x is greater than 1, differentiation of this, sec square x minus 1 plus x minus 1. Sec square of x minus 1 plus x minus 1 differentiation will be minus 1 only, right? Okay, plus x minus 1. So plus 1, sorry, plus 1. Right? And here differentiation will become minus of sec square x minus 1 minus 1. Minus of sec square x minus 1 minus 1. This will become minus sec square x minus 1 minus 1. Now tell me, LHD and RHD are equal? No. LHD, that means this one, sec square of 0 minus 1. LHD over here will be equal to minus 1. Sec square 0 means 1. Sec square 0 means, 1 minus 1. Minus 1 minus 1. It will become minus 2. RHD, what will be RHD? Right hand derivative at 1. Sec square of 0 plus 1. So 1 plus 1, it will be equal to 2. RHD and LHD will be different. RHD is 2 and LHD is minus 2. So this is not differentiable at x is equal to 1. We can directly say that. Right? Found the derivative and then LHD and RHD at x equal to 1. Both are coming out to be different. So it is not differentiable at x equals 1. Did you also think that none of these would be the answer? No. Okay. Remember this thing. This thing is written importantly. X minus a mod of x minus a. X minus a into mod of x minus a is always differentiable at x equal to a. Right? That was majorly used in this question. I think this was a PYQ, but anyway, it is not mentioned then. Okay, not a problem. Okay. Now let's look at this question. Now see, f of x is equal to x square minus 1 into mod of this plus thing. Okay, so let me write like this, x minus 1 into x plus 1. Okay, what is this? X minus 3 into x minus 2 it will become, right? Factorize this and cos of mod x will always be equal to cos x. Try this once. I think you can easily do this. It's an old question. I'm sorry, just a minute. Mod of, what will be this? This will be mod of minus 1 minus 2. So x minus 1 into mod of x minus 2 plus cos of mod x will be cos x only. Is not differentiable at which points? It will be differentiable at 1 because of x minus 1 and mod of x minus 1. It will be differentiable at 1. It will be differentiable. X minus 1 into mod of x minus 1 will be differentiable at, this function will be differentiable at 1. At 1 there will be no problem, because for this entire function only at 1 there is a problem. This is always differentiable and this is not differentiable at 1. This is not differentiable. This could be not differentiable at 1 and 2. But we saw that x minus 1 into mod of x minus 1 is making it differentiable at 1. So at 1 there is no problem. Okay. At 2, this is always differentiable and this is non-differentiable at x is equal to 2 because x mod of x minus 2 is there. there is nothing else which is also becoming 0 at x is equal to 2. This mod of x minus 2 is a problem. At 2, this entire thing will be non-differentiable. This entire thing will be differentiable at x is equal to 1 because of x minus 1 into mod of x minus 1. This x minus 1 will make the entire x minus 1 into mod of x minus 1 differentiable at x is equal to 1. But mod of x minus 2 is not multiplied with x minus 2. Here there is a x plus 1. So this will remain non-differentiable at x is equal to 2. This is always differentiable. Always differentiable plus non-differentiable at x is equal to 2. That means this is not differentiable only at x is equal to 2. எப்படி இருக்குங்க நல்லா இருக்குங்க ரோஷன் நீ எப்படி இருக்குங்க நீ எப்படி இருக்கு Now correct, understood, this is always differentiable, this is non-differentiable at x is equal to 2. So entire thing will be non-differentiable at x is equal to 2. Differentiable plus non-differentiable at x is equal to 2 will give me non-differentiable at x is equal to 2. Understood? Cos x is always differentiable. Here it is differentiable at x is equal to 1 but not differentiable at x is equal to 2. At x is equal to 1, no problem, because x minus 1 has come to make it differentiable at x is equal to 1. But x minus 2 should be there outside to make it differentiable at x is equal to 2, but it is not there, so it will be non-differentiable at x is equal to 2. Yeah, na Tamil pesra nee sirpa. I know very little of Tamil, and that too very, I understand if somebody speaks, no, I'll understand. Movies and all I'll watch without subtitles, but speaking, it's a little difficult for somebody who has spoken Hindi from the childhood, because many words like and all are still very difficult for me, but I'll try my best. I'd do anything to learn Tamil, to speak. Someday I'll be able to speak very fine. If I shift to Chennai, for some time, pakka. But I don't know what happens to Chennai in every November and December. Floods will definitely come. I have encountered one of the worst floods of Chennai. I think this was 2016-17. My God, 15, 16 or 16, 17, I don't exactly remember. But those floods were mind-blowing. I literally had to Ola boats carried me out of my house and dropped me near the highway. Then I came to Bangalore. But it was an amazing experience. Amazing, I'm saying, because it was horrifying. And how helpful people can be for one another, that's I realized in those floods only. People helped me so much that I actually felt that this place is amazing. I was stuck in water till, in my room, water was still here for me. But eventually, yeah, people saved me. If you have heard about those floods, they were horrible, man, horrible. At x is equal to 2, it is clearly non-differentiable. Now let's come upon this. Now see, this also will be able to do very easily. Sine of mod x minus x is always differentiable at x is equal to 0. Just now we discussed sine of mod x minus mod x is differentiable at x is equal to 0. We saw this just now, right? Where did it go? Sine of mod x minus mod x is differentiable at x is equal to 0, but sine of mod x plus mod x is not differentiable at x is equal to 0. So let's come upon here again. Now in this function, you see sine of mod x minus x is there, which is differentiable at x is equal to 0. Correct? 2 into x minus pi. Now what are they saying? Let k be the set of all real values of x where this function is not differentiable. Then set k is equal to what? There could be only one. See, mod is there, so there could be only one problem. This function sin x is always Sin x is always differentiable. Sin x minus x will be differentiable. 2 into x minus pi, what will be the problem? It will be differentiable. Yes, Roshan, thank you. God bless you, man. Pukka local boy, you'll become I'll pakka. I wish. Okay, sine of mod x minus mod x is going to be differentiable at x is equal to 0, and this entire thing only had trouble when x was 0, right? Mod x will only create trouble at x is equal to 0, correct? But sine of mod x minus x entirely became differentiable at x is equal to 0. Here also only at x is, here there was no problem. 2 into x, 2x minus 2 pi, linear thing, always differentiable. This is also differentiable, always. Only at x is equal to 0 there could be a trouble because of mod, but this is now differentiable because sine of mod x minus mod x will be differentiable at x is equal to 0 also. So this entire thing is always differentiable. This entire thing is always differentiable. There is no problem at all. Getting my point? Yes or no? So this will have no problem at x is equal to 0. There will be no problem at x is equal to 0. The only trouble was x is equal to 0. We had to check near 0. If we'll go by the normal approach also, there is over here, it is over here. If you go by the normal approach, we'll check near 0 because of mod x. Mod x will create trouble only near 0. Sir, where is Akash? Yeah, maybe he must have got occupied, beta. There are reasons. Okay, there can be some reasons. Even I could not interact from last 5-6 days. There could be some involvement. Okay, mod x will check near 0. So for x greater than 0, the function will become this, right? Its derivative will become this, right? Now f dash x at 0, if we'll check, derivative will become this thing, cos x minus 1 plus 2 into this. So entire derivative will become this. F dash x will become this, right? Now this entire thing is differentiable for x greater than 0. It is always differentiable for all x greater than 0. Cos x is always differentiable. N cos x, k cos x, k sin x will also be differentiable. So this entire function will be differentiable for all x greater than 0. Now for x less than 0, if x is less than 0, your function will become, this will open with minus sign. So minus sin x plus 2 into x minus pi cos x, correct? Its differentiation will become, f dash x will become minus cos x plus 1 minus 2x minus pi into cos x will become sin x plus cos x, right? Product will be applied over here. So f dash x is coming out to be this, which is also always differentiable. This entire thing, cos x differentiable, this thing will also be, sin x function will also be always differentiable. So the function is differentiable for all x greater than 0 and function is differentiable for all x less than 0 also. And at 0 it is, by observing what we can say that for x is equal to 0 also, at 0 also if we check the RHD and LHD, at 0 function will be 3, this will become sine of 0 minus 0 plus 2. So 1 plus 2, 3 minus 2 into 1, it will become RHD will be becoming 2, LHD will be becoming 2, sorry, x greater than 0 na. So RHD will be becoming 3 minus 2 minus 1, that means 3 minus 1, that means 2. LHD will become 1 plus 1 for x less than 0. LHD will become 1 plus 1, this will become 0, right? Cos of 0, 1 plus 1, that means LHD will become 1 plus 1, 2. Both RHD and LHD at 0 are equal. So LHD is equal to RHD, and at x is equal to 0 also, they are differentiable. So that means they are forever differentiable. This function is forever differentiable at all x, for all x, all real x. That means k is, there is no value in the set k. There is no value in the set k. But we did not have to do that much because now we have remembered, if we remember the results, we know only problem can occur at x is equal to 0. We'll only have to check at x is equal to 0. At x is equal to 0, this part is differentiable. Differentiable plus differentiable, differentiable. Correct? So there is no, it is always going to be differentiable. We can directly comment on that. This one by graph, can you check directly? Can you check this one directly by graph? Just imagine the graph of this. Mod of x minus 1, mod of x minus 1 graph will be like this. Here we'll be having minus 1. But mod over mod of x minus 1, now this will become like this. Mod over mod of x minus 1, that means this part which was going down will also come up. Correct? Here there will be minus 1, here there will be plus 1. Right? If we, this point which was coming minus 1 now will be plus 1. Correct? This is 0. So it is always differentiable except minus x is equal to minus 1, x is equal to 1. At x is equal to minus 1 we have a sharp point, at x is equal to 0 we have a sharp point, and x is equal to 1 we have a sharp point. So directly by looking at the graph we can directly say that this is differentiable. So many times if you are able to imagine or make the graph of the simple function, if the simple function is given to you and you can make the graph, by graph it is better and faster to evaluate whether the function is differentiable or not, and if it is not differentiable then at which points it is not differentiable. So it is not differentiable at x is equal to minus 1, at x is equal to 0, and x is equal to 1. 3 points will be there, right? Simple mod of x minus 1 graph you had to, this is mod of x minus 1, here there will be minus 1. Correct? This will be minus 1 plus 1. This will be y minus 1. So this part will come up because mod is over the entire thing. That's how you can easily incorporate the graph over here. Okay, one more question we can see with the help of graph only. Here also if you can make the graph very easily. This is 2x square plus 5x minus 3. This is a polynomial function. Whatever is this, this is a polynomial function. What are they asking? If m and n denote the number of points where f is not continuous and not differentiable respectively, then m plus n is equal to, and this question is last year's question, 24 only. Okay. Now with graph, how easily we'll be able to see this? See, polynomial function, always continuous. So can I directly say m is for not continuous? So m will become 0 because there will be no point of discontinuity. Polynomial function, always going to be continuous. Always it will be continuous. Only objection might be on differentiability. Correct? Now for differentiability, this is a polynomial function. How will be a graph? 2x square plus 5x minus 3. That means 2x square plus, mod is over x also. So we can have 2x minus 1 x plus 3 or 2x plus 1 into x minus 3. So graph is going to be somewhat like this. Correct? It will, here there will be minus 1 by 2 and there will be 1 by 2, and we'll have to remove this part and make it positive. So it will look like this. Wait, minus 1 by 2, from minus 1 by 2 it will go like this. And here it will be a sharp point. Here it will be a sharp point. This will be equal to 3. This will be equal to 3. This will be 3. This point will be 3. So there will be 3 points of discontinuity. We can clearly say it will always be 3 points of non-differentiability. It will be always differentiable except at minus 1 by 2, 1 by 2 and 0. Correct? Only 3 points of non-differentiability will occur. So n will directly come out to be equal to 3. What if they asked m plus n? So m plus n will come out to be equal to 3. By graph, it could be solved very easily. With graph, we can see this question being always continuous because polynomial. Right? Only now differentiability can be seen with the help of graph. Graph, if we can plot, this is how the graph is going to look, and at 3 points we are getting non-differentiability, sharp points. This point is sharp, this point is also sharp. We are making the minus 3 wala portion in the positive side. So this point is definitely sharp. Okay, this point is sharp, this point is sharp, 3 sharp points, 3 points of non-differentiability. N became 3 and m plus n became equal to 3. Let's see over here. Here also we can see with the help of graph only, very easily we'll be able to see the graph. If you remember the tan inverse x ka graph. So tan x graph is somewhat like this. No, ulta I made. It's going to be like this. Tan x. So tan inverse will become, we are checking for 1 and minus 1, right? So reflection will be like this, right? Reflection along y is equal to x. So reflection of tan x along y is equal to x will give us tan inverse x graph. Graph of tan inverse x will get just like that. Just quickly try to recollect your tan inverse x graph. Okay, this is going to be your, the blue part is going to be your graph of tan inverse x. Now first let's make so we have to check near 1 only, no problem. This is how your tan inverse x graph goes. This is 1, this is your minus 1, correct? I hope I have made it. Now what are they saying? We have to shift it pi by 4 up, pi by 4 plus tan inverse x it is. Okay, pi by 4 plus tan inverse x it is. So it will be shifted a little bit more. Right now it is, right now this point is pi by 4. This point is pi by 4 over here. This is your pi by 4. So you'll have to shift it pi by 4 up. Wait, yes, correct, pi by 4 up, it will be shifted. So this point, oh, okay, y-axis point we don't need to bother about. This point over here, it will become pi by 4, correct, not a problem. Yeah, this will be a graph of pi by 4 plus tan inverse x, correct, right? Pi by 4, I have shifted it above, right? This is your 0, 0. This is your origin. Pi by 4, it is shifted upside, correct? And this part, mod of x minus half. So half it will be down and will bring everything on the upside. So here it will get connected, and then from here it will get connected, right? Half mod of x minus half, half mod of x minus half, right? Mod of x minus half will be down, but mod is over the entire thing. For x is equal to greater than 1, for a mod x being greater than 1, so for x less than 1, for x less than minus 1 and x greater than 1, this part will be your graph, correct? Hope I have plotted the graph correctly, right? This part would have been like this, but this part will be cancelled because of mod, right? Mod x minus half would be like this. Okay, so now we can comment upon its differentiability and continuity, both continuous and differentiable on r minus minus 1. On minus 1 it is continuous but not differentiable because sharp point is occurring, right? Minus 1 is connected, minus 1 will be connected, sharp point is occurring at minus 1, so it is continuous but not differentiable. First option is going to be wrong. This is a void point, okay, and both continuous and differentiable on r minus 1. At 1, okay, at 1 it is not even continuous, so this is also wrong, this is also wrong. First is saying both continuous and differentiable at r minus minus 1, and minus 1 it is continuous but not differentiable. Okay, so continuous on r minus minus 1 would be correct, yeah? should be not correct, right? Both continuous and differentiable on r minus 1. At 1 also it is not continuous. Okay, so this is wrong, this is also wrong. At r minus 1, at 1 it is not continuous. Okay, no problem. But at minus 1 also it is not differentiable. At minus 1 it is continuous but not differentiable. So second also wrong. Continuous on r minus 1 and differentiable on r minus 1 and plus 1. Continuous on r minus 1. Everywhere it is continuous except minus 1. No, this is wrong because it is continuous at minus 1 also. At minus 1 it is connected. So third option also wrong. Continuous on r minus 1. Continuous on r minus 1 and differentiable on r minus 1 and plus 1. Yeah, it is continuous everywhere except this point. At 1 it is not continuous. Differentiable everywhere except 1 and minus 1. So fourth one would be correct. Graphically it will be easier for you if you can make the graphs. It will be easier for you to comment upon differentiability and continuity. So while doing functions, do the graphs of the functions also very carefully. Then continuity and differentiability will be a piece of cake for you, will be a cakewalk for you. See the graph, it's made over here. So minus 1 to 1, yes, this was correct. Pi by 4 they shifted, and for mod of x minus 1 by 2, this will be x mod of minus of x plus 1 by 2 from here to here, and this will be x minus 1 by 2 from here to here. This will be not connected, right? This will be not connected. Correct. One more question, last year's only. Let's see. Here they are saying if the function f of x is this, is differentiable on r, for everywhere on r, or for all real numbers, then 48a plus b is equal to what? They have given that it is differentiable. So definitely LHD and RHD or continuity will have to use. Either will have to use continuity or differentiability. So if it is differentiable on r everywhere, that means it should be continuous. So we'll check continuity at 2, because for 2 we are given values. So we'll check continuity at x equal to 2. At x is equal to 2, LHD and RHD. What will be LHD? LHD, that means, sorry, RHD. What will be RHD? When x is greater than 2. Mod x is greater than 2. Right? Mod x is greater than 2. That means x less than minus 2 and x greater than 2. Greater than equal to 2. So your RHD, if we check continuity at x is equal to 2. Suppose we are checking continuity at x equal to 2. At x equal to 2. So RHD x greater than 2 will give us 1 by 2. 1 by 2 will be equal to, this will be your RHD. RHL, why I am saying RHD, RHL it will be. LHL will be less than 2. Mod of x, x between minus 2 and 2. That means LHL will be x less than 2. So minus 2 and 2 will come over here, ax square plus 2b. So it will become a by 4 plus 2b. At 2 we are checking, no? So a by 4 plus 2b at 2. Okay, we can check continuity at x is equal to minus 2 also. Continuity at x is equal to minus 2 also. Continuity at minus 2, check properly. 1 by 2 will come on LHD definitely, and RHD will become minus a by 4. No, we are getting the same result. We are getting same result at minus 2 also. We are getting 1 by 2 equal to a by 4 plus 2b. So let's go on differentiability. Let's check differentiability at x is equal to 2. LHD we got one result. With differentiability also we'll get one result. Minus 1 by x for x greater than 2. RHD, that means for x greater than 2, minus 1 by x will become minus 1 by x square. At x is equal to 2, x greater than 2 will get this. So minus 1 by x square will become equal to this differential 2a. 2a plus 0. Oh, sorry, 2ax. Minus 1 by x square will become 2ax. At x is equal to 2, what are we getting? Minus 1 by 4 is equal to 4a. Minus, this will become minus 1 by 4. This will become 2 into 2, 4a. So your 4a is equal to minus 1 by 4. That means your a is equal to minus 1 by 16. A equal to minus 1 by 16. What will be b? Minus 1 by 16, 64, minus 1 by 64, it will become, oh my god, too much of calculation. So from here we'll get 2b is equal to 1 by 2 minus minus 1 by 16, no? Minus 1 by 64, so plus 1 by 64. B will come out to be 2 3s are 8, 8 will come up. 3 by 8, check once, B will come out to be 3 by 8. If A is minus 1 by 16, B will come out to be 3 by 8. Yeah, B will come out to be 3 by 8. Now what did we have to find? We had to find 48A plus B. So 48A plus B will become 48 into A, that is minus 1 by 16 plus 3 by 8. Again calculation. So 48 into minus 1 plus 6 by 16. Okay. So 6 into 5 by 2, that means 30 should be the answer. No, 2, 3, 15 should be the answer. Did we have options here? No, we didn't have options. 15 should be the answer. This will be your answer. Just check once on your own. Check once. Okay, 15. As far as I remember, yes, 15 was the answer. Okay, 15 should be the answer. 15. Now, last thing, differentiability in an interval. When we spoke about continuity in an interval, same thing will be applied for differentiability also in an interval. In open interval, there is no problem. If f of x is differentiable, for example, if f of x is said to be differentiable in open a to b, open interval of ab, then it should be differentiable at every point between a and b, right? If f of x is said to be differentiable in open interval AB, then for every point between A and B, it should be differentiable. For example, this is also open, this is also open. If f of x is differentiable in this interval A to B, then for every point between A and B, it will be differentiable. That's what it is saying. It's just like continuity. For closed interval, same like continuity only. For closed interval, the problem here, A and B is closed interval. That means these points are closed. For closed interval A and B, this means first thing that it should be differentiable for all x between A and B. For all x between A and B, it should be differentiable. Right hand derivative, that means this right hand derivative at A should exist, right? And left hand derivative at B should also exist. We don't need to worry about left hand derivative at A and right hand derivative at B, but right hand derivative at A should exist and left hand derivative at B should also exist. Just like in continuity, right hand limit should exist at A and left hand limit should exist at B. That means it is continuous. Now, sorry, in continuity we said left hand limit at B should be equal to f of B and right hand limit at A should be equal to f of A. So here we'll say right hand derivative at A should exist and left hand derivative at B should also exist. Then we can say that f of x is differentiable in closed A and B, right? Closed A and B. That's how we are going to put it. Okay, then. Oh, we did this, right? Okay, that was all. This is purely definition based. In interval, if they are asking you to check, so you have to check like that. You have to check like that. That's all from me. Continuity and differentiability combinedly, please study it together, solve as many questions as you can. If some type of questions are remaining which we didn't discuss, please put it in the comment box so that I can discuss those also. If you're expecting any particular variety to be discussed which you're seeing in your books or in PYQs, let me know in the comment box. Subscribe the channel, right? If you're seeing without subscription, you'll not be updated on the upcoming lectures on this channel. So please subscribe the channel, like the video if you can. I won't ask you or nag you for that, but if you like, then like. Rest, please keep studying. For 2025 aspirants, the time is coming near. If you are listening to this, stick tight, keep working hard. You are going to achieve it. Don't worry about it. Okay, don't worry, you are going to achieve it. There are small updates which are there, for which I'm going to upload a video in a day or two, which you must have which you must gotten, which you know already, the update of NTA. I'm sure if you're a 2025 aspirant, then you know the update also. Don't get panicked because of that update. Focus on the complete syllabus. That should be your main key. All right then. So thank you. Take care. Bye bye.